chi-squared question, and it's a chi-squared test for independence. And we can see that here it's written in the question. We can also see that we're going to be using a 5% significance level. So for the first part of the question here, you're asked to write down what the null hypothesis is, and you need to write down that they are independent. So that's the key word that we're looking for. We should not have any mention of correlation or affecting one another. It should be the word independent. So the null hypothesis is that the number of salads eaten or bought, maybe, don't actually know they've eaten them, is independent of the role at the university. And then we need to calculate the p-value for the test. So to do this, we're going to go across and create a matrix. And we can see there that the matrix should be, if we edit this, we need to have 4 by 3. So the first one is 45, 15, and 16. So that's no salads per week. And then we have 26, 8, and 13, 18, 5, and 10. And then the last row, the last column, sorry, is 6, 12, and 6. So we can now create this. So we're going to do a statistics and a test, and we are doing a chi-squared. Here we go, chi-squared test for independence. So we select this option. Observed is in A, that's why I saved it. It's always straight into A, and then we can calculate. And we can see there that the p-value is 0.021 to 3 significant figures. So the p-value equals 0.0201. Okay, so that's my 3 significant figures. And we need to state, giving a reason, whether it should be accepted or declined. So my p-value is 2%. So the p-value is roughly 2.01%. And my significance level is up at 5. And that means that the p-value is very small. When the p-value is small, we reject the null hypothesis. So we say that 2.01% is less than 5%, or the p-value is less than the significance value, and therefore we reject the null hypothesis and we accept the alternate, which you can write as either HA or H1.